Okay, so for this deep dive, we're going to be focusing on something I think a lot of folks find challenging as they're preparing for senior software engineer interviews.
Okay.
And that's design patterns.
Yeah, yeah.
And, it's one thing to just kind of have heard of the various design patterns, being able to list them off.
Right.
But being able to really talk about them in depth and understand how they work and why you would choose one versus another.
Right.
I think that's where...
yeah, that's where the rubber meets the road.
That's where the rubber meets the road, right?
Definitely.
So we're going to try to tackle one today.
Okay.
And it's a pattern that I've personally found really useful over the years for decoupling parts of a system.
Okay.
And that's the chain of responsibility pattern.
Okay, yeah.
So the basic idea, I think a lot of people have at least kind of a surface level understanding of this. You've got a sequence of objects.
Right.
And a request comes in, and it kind of gets passed along this chain.
Yeah.
Until one of those objects
is able to handle it.
Yeah.
Yeah.
So what's really interesting about this pattern, and the reason I think it's so valuable, is it kind of creates this situation where the thing that needs something to happen, let's say, doesn't need to have specific knowledge of what's going to do it.
Right.
It just kind of says, hey, I need this thing.
Here you go.
Here you go. And sends it off into the chain.
Right.
So maybe a good way to maybe illustrate this would be, and this is a situation that we've probably all run into when developing software.
Okay.
You've got some kind of GUI with, buttons, dialog boxes, the usual stuff.
Right.
And let's say a user clicks a help button.
Okay.
Right.
Yeah.
And maybe the help information that would be most ideal would be specific to that button.
Right.
Right. So here's what this button does. But what happens if there's no help defined for that specific button?
Right.
And this is where this pattern, I think, really shines, because instead of that button needing to have knowledge of, oh, well, if I don't have any help, maybe my parent container, which is, let's say, a dialog, does. Or maybe it's the application as a whole.
Right.
You don't need all that coupling.
Exactly.
You can just kind of say, hey, I need help.
Right.
And first it checks, can I handle this? The button checks, can I handle this?
Right.
Nope, I can't. Okay, pass it on up. Maybe to the dialogue. The dialogue checks, do I have any help information?
Right.
And if not, maybe it passes it up further to the application level.
Right. Exactly.
And so what you get is this kind of like the actual receiver is almost implied.
Yeah, it's implied. It's not explicit. It's not like that button knows that the application is going to handle it.
Right. And so that's one of the real, I think, strengths of this pattern is that you kind of reduce the need for these, direct connections between every possible.
Right. Exactly. You've got these objects that don't need to know anything about the overall structure of the application or the other objects.
Right.
They just know, hey, if I can't handle this, I'm passing it on. I'm delegating this responsibility.
Right.
That's really the core principle here, delegating the responsibility to handle it.
So let's dig into kind of how that chain actually works, kind of at a fundamental level.
Right.
So what's the mechanism by which, a request?
Okay, so the request comes in.
Yeah, a request comes in.
And this could be, like you said, a help request. This could be something totally different.
Right.
This could be processing a new order in an e-commerce system.
Right.
So the request comes in, and it gets passed sequentially from one object to the next.
Okay.
And each object in the sequence kind of examines the request and says, okay, am I the right component to deal with this? Right? And if so, great, it handles it.
Okay.
If not, it forwards it along to the next object in the chain.
Right.
So it's kind of like a relay race in a way.
Okay.
You've got this baton, which is the request, and you're passing it along.
Okay. So maybe we can make this a little more concrete. You mentioned the e-commerce example.
Yeah.
So let's say you got an online retailer, Mighty Gumball, let's say.
Okay.
And they get all kinds of emails coming in, right?
Yeah.
You've got spam, you've got fan mail, you've got complaints, you've got people saying, hey, I'd like to propose a new Mighty Gumball location in my town.
Exactly.
All kinds of stuff coming in.
Yeah.
So how might you use a chain of responsibility to handle all those different kinds of requests?
So let's imagine that Mighty Gumball, they're a cutting edge company.
Okay.
They've got this really awesome AI.
Okay.
that can actually look at an incoming email and identify what type of email it is.
Okay.
So right away, we know, okay, this is spam, this is fan mail, this is a complaint.
All right.
So now that we know what type of email it is, we can pass it along to a chain of handlers.
Okay.
So we might have a spam handler. That's the first handler in the chain.
Right.
And spam handler says, hey, is this spam?
Right.
If it is, great. We just delete it. We don't need to deal with spam.
Right. Into the bit bucket.
Exactly. If it's not spam, it gets passed on to the next handler in the chain.
Okay.
Maybe that's the fan handler.
Okay.
And fan handler says, okay, is this fan mail?
Yeah.
And if it is, great, I'm going to forward this on to the CEO. The CEO loves reading fan mail.
Right.
If it's not fan mail, we pass it on to the next handler in the chain. Maybe that's the complaint handler.
Okay.
Is this a complaint?
Right.
If so, let's send it over to the legal department.
Okay.
And then finally, maybe there's a new lock handler.
Okay.
Is this a request for a new location? If so, we're going to send it to the business development team.
Okay. So you can imagine at the end of that chain, you might also have some kind of catch-all handler.
Right. That's a good point, yeah. You might have something at the end of the chain that just says, look, if we've gotten this far, we don't know what this is.
Right.
Let's just, maybe flag it for manual review.
Right. Or maybe log an error or something like that, right?
Exactly. Exactly.
So it's interesting because that also kind of highlights a potential downside, right?
Yeah.
Which is that it's possible for a request to go through that entire chain and not actually be handled.
That is true. That is true. It's possible.
If it doesn't match anything.
If it doesn't match anything, it might just fall off the end of the chain.
Right.
And that's something that you need to think about when you're designing the chain.
Right.
You need to make sure that, okay,
is there always going to be...
are we handling every possible scenario?
Right.
Or is there a way for something to slip through the cracks?
Yeah, and if so, what are we going to do about it?
Right. Exactly.
Okay, so let's talk about the kind of core components of this pattern.
Sure.
So what are the kind of building blocks, the essential things that you need to make this work?
So at its heart, you have what we call an abstract handler.
Okay.
So this is usually an interface or an abstract class.
Okay.
And it defines a method for handling these requests.
Right.
So it might be something like process request.
Okay.
And what's really important is that it also includes a mechanism for holding a reference to the next handler in the chain.
Okay.
And this is what we often call the successor.
Okay, so each component in this chain has
a link to the next
one. Okay.
Exactly. And then you have what are called concrete handler classes.
Okay.
And these are the actual implementations of that handler interface.
Okay.
So each concrete handler, this is where the specific logic for handling those requests that it's responsible for lives.
Right.
So when it receives a request, it
first determines, okay, can I handle this?
Right.
And if it can, great, it performs the actions.
Okay.
If not, it forwards that request along to its successor, using that reference that we talked about.
Right.
So in our Mighty Gumball example, spam handler, fan handler, complaint handler, new lock handler, those would all be concrete handler classes.
Okay. And then what about the thing that's actually kicking off the whole process?
Right.
How does that come into play?
So that's what we call the client.
Okay.
The client is the object that creates the request and sends it off to that first handler in the chain.
Right.
And what's really important to remember is that the client doesn't need to know the structure of the chain or which specific handler is ultimately going to deal with this.
Right. It just knows, here's the first one.
It just needs to know where to send the request.
Right. So if you were to picture like a UML diagram, you would have, the handler with its process request.
Yeah. And then you'd have all these different concrete handlers.
Exactly.
And then the client would kind of be off to the side and would know how to send the request to the first handler.
To that first handler.
Okay.
And you'd see that successor relationship there in the UML diagram.
Right.
Each handling pointing to the next one in the chain.
Right. We also talked about another way of structuring this where instead of an explicit successor link, you might be using existing relationships between objects.
Yeah, and that's very common in GUI applications.
Okay.
So think about it.
Yeah.
In a GUI, you have elements nested within each other.
Right.
So a button might be inside a dialog, the dialog might be inside a window, and so on.
Yeah.
So if that button can't handle a particular event, like our help request, it can delegate that responsibility up to its parent, which would be the dialog.
Right.
If the dialog can't handle it, it passes it on to its parent, which might be the application window. Right.
And so in that way, you have a chain of responsibility that's formed by the containment hierarchy of the GUI.
So the successor in that case is
basically just the parent.
The parent
in that tree structure.
Okay. And we looked at a sequence diagram that's kind of showed this, where you had a button, a dialogue, and then the application, and you could see the handle help kind of going up.
Going right up the chain.
Right.
Yeah, you can visualize it very clearly.
Yeah, and then we also saw kind of the opposite, the object diagram.
Right.
Which is more of a runtime view, right?
Yeah.
Where you've got the client connected to a concrete handler.
Right.
And that's connected to another concrete handler.
Yeah.
Through that successor.
Through that successor link. Exactly.
Yeah. Okay. So we've got a pretty good understanding of kind of the mechanics of it.
Yeah.
So what are some of the advantages
of
using this pattern? What makes it a good choice in certain situations? So one of the biggest advantages, and we kind of alluded to this, is that it reduces coupling.
Okay.
So the object that's sending the request, it doesn't need to know which object is going to handle it.
Right.
It just needs to know where the chain starts.
Right.
And this makes the system much more flexible.
Okay.
Because changes in one part of the system are less likely to affect other parts.
Yeah.
If you decide to change the way you handle spam, that shouldn't affect how you handle complaints, for example.
Right. So it's kind of like, those systems where it's like, oh, if you touch this over here, this completely unrelated thing over here breaks.
Yeah, you don't want that. You want to avoid that.
Right.
And this helps you do that.
Okay.
Another big advantage is flexibility in terms of assigning responsibilities.
Okay.
So you can add new handles to the chain.
Okay.
You can remove handlers. You can change the order of handlers.
Okay.
All at runtime.
Okay.
Without having to modify the client code. Without even having to modify the existing handler classes.
Okay. So it's kind of like you can on the fly reconfigure how the system's going to respond to certain events.
Exactly. So let's say in our order processing system, Mighty Gumball, suddenly they just say, we need to add a fraud detection step.
Okay.
Well, great. You just add a new fraud detection handler to the chain. You don't have to change the way you handle inventory.
Yeah.
You don't have to change the way you take payments.
It's just a new link in the chain.
It's just a new link in the chain.
Okay. So very modular in that sense.
Very modular. Exactly.
Okay. So we've talked about good things.
Yeah.
Are there bad things? Are there drawbacks to using this?
There are. No pattern is perfect.
Yeah.
And there are some trade-offs here.
Okay.
So one important drawback is that you're not guaranteed that a request is going to be handled.
Okay.
So a request could go through that entire chain and none of the handlers might be able to process it.
Right. It might just fall off the end.
It might fall off the end.
Okay.
And that could lead to some unexpected behavior.
Right. So you really have to think through.
You have to think through, okay.
All the cases covered?
Are we handling all the cases?
Okay.
Do we need a fallback mechanism?
Right. Some sort of default behavior.
Exactly.
Okay.
Another potential issue is that it can be harder to debug.
Okay.
So when you're looking at the code, it might not be immediately obvious, which handler ultimately processed a request.
Right.
Or why a request wasn't handled.
Right, because it's all kind of happening implicitly. Right.
It's happening implicitly. It's kind of this chain reaction going on.
Right.
And sometimes it can be hard to follow that trail.
Yeah, you have to kind of like step through it in the debugger.
Exactly.
Okay. So let's say we've decided, okay, this is a good pattern to use for this particular problem.
Yeah.
What are some things to think about as we're implementing it?
Okay. So one of the first things to think about is how are you going to implement that successor chain?
Okay.
So as we discussed, you can create explicit links between the handlers, maybe defining them in the handler class itself, or in the concrete handler classes.
Okay.
Or you can use an existing structure, like the parent-child relationship that you have in, say, a GUI application.
Okay.
So if you're already using a composite pattern, the parent can actually act as the successor.
Right.
That can be a really elegant way to do it.
So that would be preferable if it made sense for that particular problem.
Yeah. If the existing structure fits the logical chain that you need, then great, use it.
Okay. But if not?
If not, then you probably need to create those explicit successor links.
Okay. And how would those typically be connected?
So usually you'll have, like we said, that abstract handler class.
Right.
And it'll have a reference to the next handler in the chain.
Oh.
And it might even provide a default implementation of that process request method.
Okay.
That just basically forwards the request if there is a successor.
Okay.
And this makes it really easy for those concrete handlers that aren't actually interested in a particular type of request.
Yeah.
I don't have to do anything. They just inherit that default behavior.
So it kind of simplifies the code in those cases.
It simplifies the code, exactly.
Okay. And then the next thing to think about, I guess, is how are you going to represent the requests themselves?
Yeah, good point.
You know, we saw a few different approaches.
Right.
So one would be just to have hard-coded
operation invocations.
like you said, handle help.
Exactly. Handle help.
You know, something very specific.
Right.
So that's simple.
Very simple.
But obviously not very flexible.
Not very flexible. Right. If you have a lot of different types of requests, that's not going to work very well.
Okay.
Okay.
Another option would be to have, you know, a single handler function that takes some kind of request code.
Yeah.
So you might have an integer that says, you know, 1 is spam, 2 is a complaint, 3 is this.
Exactly.
What are the trade-offs there?
So that's a little bit more flexible because now you can handle different types of requests with a single method.
Right.
But now you're going to have a lot of conditional logic in your handling.
Right. You're going to have a big if statement or switch statement.
Exactly. A big if statement or a big switch statement.
And it also doesn't really give you a lot of type safety. Right.
Right. And it can be a bit harder to read and maintain.
Okay.
So a more robust approach
is
to use what are called request objects.
Okay.
So in this approach, you're creating separate classes to represent each type of request.
Okay.
So you might have a help request object, an order request object, a complaint request object.
Right.
And each of these objects encapsulates
the
specific data that's relevant to that type of request.
So a help request would have, you know, which component needs help.
Exactly. It might have the ID of the button or the dialogue that needs help.
Right.
An order request would have the items that were ordered, the quantities, the payment information.
Right.
So now each handler can just look at the type of the request object and say, okay, I know how to handle this.
Right.
And it can access those specific pieces of information.
And it can cast it to that type. Right.
Exactly.
And then access the, you know, the specific methods or properties.
Exactly. So it makes the code much cleaner and much more type safe.
Yeah, we saw that example where the handle request function would take a request and it would use like a get kind method or something like that.
Exactly.
You know, to determine what type of request it was.
Yeah.
And then you could, you know, cast it.
Right.
You also briefly mentioned something kind of interesting in small talk.
Yeah.
That does not understand mechanism.
Right.
Can you talk a little bit more about that?
Yeah. So in small talk, if an object receives a message, it doesn't have a corresponding method. For the doesn't understand method is invoked.
Okay.
And you can override this
Okay.
to implement automatic forwarding to the next object in the chain.
Okay.
So what this means is that you don't actually have to explicitly implement the forwarding logic in each of your concrete handlers.
Right. So it's kind of like the language has built-in support for this pattern in a way.
It kind of does. It kind of does. Yeah. It makes the code very clean and elegant.
All right. So where do we typically see this pattern being used in real-world systems?
So one very common example is in GUI frameworks.
Okay.
So systems like MECAP, ET++, TCL, they've used this extensively.
Okay.
And they often call it an event handler or a responder.
But it's the same basic idea.
Yeah.
You've got an event like a mouse click or a key press.
Okay.
And it gets passed along that hierarchy of UI elements until one of them handles it.
Right. So it's almost like a natural fit for that kind of, you know,
fits really
nested structure.
It fits really well.
Another area is in command processing.
Right.
So you mentioned Unidraw.
Right. In Unidraw, you have these command objects that represent actions to be performed.
Okay.
And those commands can be passed along a chain of components.
Okay.
And the first component that can execute the command handles it.
So the command itself is kind of the request.
The command is the request. Exactly.
Being passed along.
Yeah.
Okay.
And ET++ also uses this for graphical updates.
Okay.
So you might have an operation like invalidateRect,
okay,
which basically says, hey, this part of the screen needs to be redrawn.
And that can be passed up the chain of graphical objects until it reaches a window or a view that can actually handle the redrawing.
So it seems like it works really well with these kind of hierarchical structures.
It does. It does.
Like we see in composite patterns.
Yeah, it often goes hand in hand with the composite pattern.
Okay. So to kind of summarize here, the chain of responsibility pattern is really all about
decoupling.
Decoupling, right.
Decoupling.
You know, you've got the sender of a request doesn't need to know who's ultimately going to handle it.
Right.
And it provides this really nice mechanism for basically saying, you know, here's a sequence of objects.
Right.
Any one of them could potentially handle this.
Exactly.
I'm just going to pass along and let the chain figure it out.
The chain figure it out.
So big advantages are decoupling, flexibility.
Flexibility.
But you also have to be aware of the fact that a request might not be handled.
It might not be handled.
And it can be a little trickier to debug.
It can be a little harder to debug, but overall, it's a really powerful pattern. I think for senior engineers especially, being able to talk about this, understanding the trade-offs, this really shows that you can think at a higher level about designing systems.
It's not just about, you know, writing code to solve a specific problem. It's about thinking about...
It's about architecture.
Architecture, right?
It's about design principles.
Yeah, how do we build these systems that are, you know, flexible, maintainable, all that good stuff.
Exactly. And that's what interviewers are looking for.
Absolutely. So for those of you who are out there preparing for those senior software engineer interviews...
Yeah, good luck out there.
Good luck. Here's a thought for you to kind of chew on as you're preparing.
Okay.
You know, think about a project that you've worked on recently and think about whether there were any places where maybe a chain of responsibility approach, expert,